Greetings, Earthlings. Today we're going to go over a very nice question. So this question is, there are 50 coins that total $1. What is the probability that I pick a dime? So I had to make this fairly brief for the description, so let me just make sure we know what the question is. So what do I mean by if I pick a dime? Well, if I know what my coins are, so let's say I have all 50 that are pennies, the probability that I pick a dime is 0 because there are no dimes. So that's what the question means. So in order to answer this, we would have to basically figure out which coins do I have. All right, so before we jump in, I want to give you guys a preview of some of the themes and techniques we're going to see here. So number one, of course, is the theme of staying organized, and that's been the theme in the previous few videos as well. So we will continue to do that, and I will mention that as we go. Number two is going to be a really powerful technique. It's one of my favorites. It's unfortunately it's not really taught very often, and I really want to kind of promote this technique. So in terms of actual skills that might be new for you guys, or new little ideas, I really want you to focus on number two here, which is the swapping technique. So I'll point this out as we go as well. Number three is, so what can seem intimidating about this problem is that there are 50 coins that total $1, and you might think, oh my God, there might be so many ways of doing this, I don't even know where to start. So oftentimes these problems are not as scary as they seem, so they're less scary than they appear. So jump in. Oftentimes you'll just jump in, you'll start listing things out, and nice things will happen. So if you thought, oh my God, there are going to be hundreds of cases, or it's 30 or 40, you might find it's really not that many cases. So don't give up prematurely. That's number three. And that's kind of a powerful life lesson in general. All right, so let's dive in. When I do this problem, the first thing I might want to do before even kind of getting my hands dirty is to do a quick back of the envelope calculation to get a sense of is this even remotely possible? And how would I do that? Well, if there's $1 and there are 50 coins, then on average, my coin value must be 2 cents. So 2 cents per coin. So what does that tell me? That means that the vast majority of my coins must be pennies. That's probably something most of you guys already intuitively knew, but I would do this anyway because you don't want to spend time looking for things if you already know that it's impossible to even get. So as an example, let's say I made this number 101 coins, right? So then your average would be below 1 cent, and that's not possible to average below 1 cent per coin. But that's just a quick little thing I recommend you guys do in general. This orients you to okay, are there a lot of pennies, a medium amount of pennies, roughly how many are there? Okay, so now let's actually do this formally. So I forgot to mention in the problem that we are told that there is at least 1/4. So 1/4, so there's greater than or equal to 1/4. That is very important. Now, here's the part about staying organized. You guys can see my little table over here. This is the number of pennies, nickels, dimes, quarters, and this will be the total. I don't recommend you guys just jump all over the place, so we're going to start very organized. Notice my numbers are going from, in terms of the large ones, the quarters and the dimes, they're going from low to high. So I'll start with the lowest, which we're told we have at least 1/4. So I have to have this to be at least a 1. Now, think of this as almost like numbers, your P, N, D, Q. So think of this as the the thousands digit, the hundreds digit, the tens digit, and the ones digit. So I want to start with the lowest number. So I don't want to increase these prematurely. I'm going to try to increase the pennies first. So the lowest number I can try is 100, and then make all the rest of the coins pennies. So that would be 49 coins, 1 coin. So in all of these rows, I ensure that I have 50 coins total every time. Now, so over here, if you have 25 cents and then 49 cents from your pennies, that's a total of 74 cents. Now here's where we're going to see the swap technique. The first thing I'm going to try to do is not touch the quarters and the dimes. So think of your D and your Q as columns. We're not going to really move a lot. We're only going to change them across cases, but within a case, we're really just playing with the pennies and the nickels. Now, the usual way of doing this is to try to kind of figure out these numbers, and it takes a lot of time. You kind of might guess and check. So I don't like that approach. So I want to show you guys how you can get the right numbers over here very quickly, and that's using the swap technique. So here's how it works. If we have 1 penny and 1 nickel, notice over here we already have 49 pennies, so that means we cannot introduce a nickel because then we'd have 51 coins. So if I want to have at least 1 nickel, that means I have to get rid of 1 penny. So there would be 48 pennies and 1 nickel. Now every time I decrease a penny by a penny and increase by a nickel, 1 penny is 1 cent, so that would be -1. Nickel is 5, so this would be +5. So -1 plus 5 is 4 cents. So this is the crux of the swap technique. You look at the differential. What happens if I swap this type of coin for another type of coin? So a penny for a nickel can increase or decrease your value by 4 cents, depending on if you're introducing the nickel or taking it away. In our case, we're going to be introducing nickels, usually. So that means if I want to know what number of nickels must I have, we're going to do this. 74 cents is 26 cents away from $1. Now 26 cents is not even divisible by 4, so actually we can stop right there. But for your benefit, just so you could see it, 26 divided by 4 is going to be 6 and some fractional part. So that's why I've taken the 49 and I bumped it down by 6. So if we decrease this by 6, we would up our nickels by 6, and indeed this gets us only to 98 cents, and we have 2 cents left over. And that's the same thing as, so $1 minus 74 cents would have been 26 cents. 26 divided by 4 is 6 remainder 2, and that's why we had this remainder 2 over here that we didn't hit $1. So there's no way we can get $1 by just wiggling pennies and nickels if we force our dimes and quarters to be 0 and 1. So that's why I have a line over here to indicate that these two cases kind of go together. I'm starting us off here, and I'm seeing how can we swap it directly to get the right value. So we want to get as close to $1 from whatever our starting point is. So that's it. This case doesn't work. It can't be 0, 1. The next thing we're going to try is 1 and 1. So 1, 1, I'm going to start as low as possible because we're staying organized, remember. So 1, 1, 0, and then all the rest are pennies, 48. So if you add up the value of all this, you should get it's 83 cents. It's 48 plus 10 plus 25. So that's 58 plus 25, 83. All right. Now 83 is 17 cents away from $1. So again, just by using this 4 cent argument, 17 is not divisible by 4. So I already know we're going to fail here as well. But just to show you guys in a little more detail, 17 divided by 4 would be 4 remainder 1. So we bump this down by 4, we up this by 4, and if you add up this new total, it's 99 cents, and indeed there's a remainder of 1. We are 1 under $1, so this is no good. So now let's try next case. So we tried 1, 0, we tried 1, 1, now let's try 1, 2. So the value of 1, 2, 0, and then all the rest are pennies is 92 cents. This is good news. Why is this good news? Because we are 8 cents away from $1, and we know that every time we swap pennies and nickels, we bump it up by 4 cents. So 8 is divisible by 4, so we know that 8 divided by 4 is 2, so that's why I'm not going to even try 46, I'm going to go straight to 45. That's the whole brilliance of the swap technique. So this goes down by 2, this goes up by 2, and voila, we get exactly $1 if you add up the value of all these coins. Now, we're not done because maybe there are other ways of doing it. So let's keep going. Let's try, we tried 1, 0, 1, 1, 1, 2. Let's go to 1, 3. So 1, 3, 0, and then everything else is 46. So, by the way, I don't have to start with 46, or I don't have to make these zeros to start with. That was just a way for me to stay organized. You could have went in the totally other direction and started off with a high number of nickels and then swapped it to get the right number of nickels and pennies. So you could either start high or start low, but just always start from one end. So let's start 1, 3, 0, 46. What is the value of this? $1.01. Now this time I won't even bother swapping because we know we're 1 cent away. And by swapping pennies and nickels, we can only move up or down by 4 cents. So this is gonna fail because we're off by 1 cent, and 1 is not divisible by 4. So next, notice we're already over $1, so if we try 1.4, that's going to be even higher. So like 1.40 and 45 would have been even worse. So that's why we don't have to keep trying 1 anything. Now we can go to 2. So with 2, the lowest we can do is 2.0. So let's do 2.00, everything is a penny. And if we add up the value of this, it's 48 plus 50 cents, that's 98 cents. Now 98 cents is 2 away from $1. And again, using our swap technique, we know that 2 cents is not divisible by 4, so there's no amount of wiggling pennies and nickels will get us there. Now, at this point, we could try introducing perhaps a dime, so going to 2 and 1. But when you swap a penny for a dime, that's going to be -1 plus 10, so that's plus 9. So this is going to get us over. So just to show you guys, this would be 47 cents plus 50 cents, that's 97 plus 10, that's $1.07. And this is, as we predicted, 9 cents above it. So this won't work either. And hopefully you guys can convince yourself, if we go any further, we're just going to get worse and worse. It's just going to get higher and higher. So that's why we're done. And we found that the only one that works is this one over here, which is 45 pennies, 2 nickels, 2 dimes, 1 quarter. So to answer the original question, we know we have 50 coins and there are only 2 dimes, which is really the only piece of information we needed. And therefore the probability is 2 out of 50. Let me move this up so you guys can see. So the probability of picking a dime, if I'm picking a coin blindly, would be 2 out of 50, because there are 50 coins total and only 2 of them are dimes. And that simplifies to 1/25, or if you want to write it 0.04, whatever works for you guys. All right, so that's how you do this problem, but I really don't care so much about the problem. Again, I want you guys to focus on how we stayed organized the entire time. Specifically, I hope this swapping technique serves you well. And by the way, you need not only use this for 2 coins at a time, you can use this for 3 coins. So you could say, what happens if I take a penny and a nickel and change it for a quarter and see what the differential would be there? So that would be like, so penny and nickel would be +1 plus 5, so that'd be +6. And then minus a quarter, well, whatever, minus 25, depending on the conditions of the problem. So the swapping technique is one of my favorite things. And again, notice how the number of rows here actually wasn't that bad. And I only put in some of these extra rows just to show you guys some examples. So we didn't have to go through like 50 possibilities. It was a small handful. All right, I'll see you guys in the next video.